Thank you to FireballMan31 for recommending this video. A while ago, I made a video explaining the universal trig substitution, also known as the Weierstrass substitution or the T-sub, and I explained where each part of the substitution comes from geometrically. And we did this construction using a parameterization of the unit circle. And I explained where the sine and cosine came from, how they became these things. But I didn't explain where dt gets its substitution from in the formula. And so that's what we're going to be talking about today. So let's go ahead and recall the setup that we had before. We start with some angle that we're going to call x. And if this is x, then we know by circle theorems that this angle over here is half of x. And we can draw some line from this part of the circle over to where it meets the original angle, and that y-intercept is what we're going to call t. And that's precisely the parameter that we have with our cosine and sine over here. Now, to figure out where dt comes from, what I'm going to do is I'm going to nudge the system a little bit. So I am going to increase the angle by some tiny amount delta x. And by the same circle theorem as before, that's going to result in a tiny change over here, delta x over 2. And this will hit the y-axis at, we're going to increase by some tiny amount in t, so we're going to call this point t plus delta t. That's our new y-intercept. Another thing that this construction relies on is remember that the way that we computed the value of t right here is that t is equal to the tangent of x over 2. And so by the same reasoning, we're going to get that t plus delta t is equal to tangent of x plus delta x over 2. Now this next part is going to require a bit of a trig identity. And the identity that we're going to be using here is the identity tangent of alpha plus beta over 2 is equal to sine alpha plus sine beta over cosine alpha plus cosine beta. And so when we go ahead and use this identity, we have a new relationship to work with. We have that t plus delta t, well, that's the same thing as x plus delta x over 2. And by this relationship right here, we have that this is going to equal sine of x plus sine of delta x over cosine of x plus cosine of delta x. And the magic from this formula comes from whenever we start simplifying this relationship here and assuming small angles. So I'm going to clean the board real quick and we'll get back to deriving the dt. Let's continue with our trigonometric journey. So this is where we left off, and we're going to use the following trick to do the rest. So we're going to do what's called assuming small angles. And that is the observation that for small angles, sine of theta is pretty close to just theta, and cosine of theta is basically just 1 whenever the values of theta we're plugging in are really tiny. And the whole idea driving this problem is that this delta x that we're nudging the system by is a very small amount. So when we assume small angles, our relationship becomes that t plus delta t is approximately equal to sine of x plus delta x over cosine of x plus 1. And this approximation gets better as we choose smaller and smaller values. Don't worry, we'll get the things we want in the end. The next trick is that we're going to go ahead and do the trig sub that we had before. So remember that whenever we do our substitution, sine becomes 2t over 1 plus t squared, delta x. And cosine of x becomes 1 minus t squared over 1 plus t squared. We add our plus 1 here. This is really messy to look at. So to go ahead and simplify things, we notice that this and this both have a denominator of 1 plus t squared. So if we multiply the top and bottom by 1 plus t squared, that'll go ahead and clear up the mess for us. And that's going to leave us with 2t plus delta x times 1 plus t squared over 2. And that's what t plus delta t is equal to. So go ahead and clear the board again, and then we'll wrap up this problem in a nice little bow. The last step in this derivation is to go ahead and get delta x by itself. So the first thing I'm going to do is I'm going to go ahead and get rid of that 2 in the denominator, and that will give us 2t plus 2 delta t is approximately equal to 2t plus delta x times 1 plus t squared. And I noticed that there's a 2t on the right side and a 2t on the left side. So we can go ahead and cancel those out. And so what we're left with is 2 delta t is approximately equal to delta x over 1 plus t squared. And finally, to get delta x by itself, we divide by 1 plus t squared. And we get that 2 delta t over 1 plus t squared is approximately equal to delta x. And now remember, I said this approximation gets better and better the smaller that our delta x and delta t get. And in the limit of this process, delta x becomes dx, and delta t becomes dt. The more mathematically sophisticated among you, just ignore the fact that I said it becomes delta x. I mean, we're not going to get into infinitesimal philosophical nonsense here. This is just a nice sort of calculus 1 sort of explanation for what's going on. But yeah, there it is. Now we've arrived to where the dt part of the substitution comes from, geometrically. Well, that wraps up everything for today's video. I hope you enjoyed it. Don't forget to like and subscribe if you have not already. And be sure to share this with a friend who you think will find this interesting or helpful. Let me know in the comments if you have any suggestions for future videos, and thank you for watching.